Hi, everyone, and thanks for joining me today for episode 743 of People Behind the Science. I'm your host, Dr. Marie McNeely, and today I am excited to introduce you to our guest, Dr. Pankaj Karande. This episode is made possible with support from our sponsor, New England Biolabs. Listeners, are you curious how molecular biology is moving forward around the world? Hear from the scientists who are driving discovery and expanding applications of existing technologies on the New England Biolabs podcast, Lessons from Lab and Life. Host Lydia Morrison interviews revered scientists working in genetics, synthetic biology, diagnostics, molecular cloning, and other fields. Get ready to explore the cutting edge of science and learn what these remarkable scientists have to offer. Don't miss out on the opportunity to hear exclusive stories about the world of laboratory research. Tune in to Lessons from Lab and Life today, wherever you listen to podcasts. And listeners, today, Pankaj will be sharing insights and stories from his life and science. So get ready to meet another one of our phenomenal people behind the science.
Every day, discoveries are made that will change our understanding of the world around us. Dr. Marie McNeely is here to bring you the brilliant minds who are making these discoveries so they can share their incredible stories and take you on an amazing journey. Welcome to People Behind the Science.
Hello, everyone, and welcome to People Behind the Science. Today, I am thrilled to be speaking with our guest scientist, Dr. Pankaj Karande. So, Pankaj, welcome to the show today. How are you?
I'm doing well, Marie. Thank you for having me.
Well, thank you so much for joining us, and we're looking forward to learning more about you and the wonderful work that you do. But before we get into the details, Pankaj, let me first take a minute to tell our listeners a little bit more about you. So listeners, Pankaj is an associate professor in chemical and biological engineering at Rensselaer Polytechnic Institute. He was awarded his bachelor's degree in chemical engineering from Mumbai University Institute of Chemical Technology and his Ph.D. in chemical engineering from the University of California, Santa Barbara. Pankaj was awarded the Anna Fuller Postdoctoral Fellowship in Molecular Oncology, and he conducted postdoctoral research in the Center for Cancer Research at Massachusetts Institute of Technology, or MIT, before joining the faculty there at Rensselaer. Now, Pankaj has received a variety of awards and honors in his career, including the Excellence in Classroom Instruction Award and the Outstanding Teaching Award from Rensselaer Polytechnic Institute. He also received the Alzheimer's Association New Investigator Research Award, the Goldhirsh Brain Tumor Research Award, and a Bronze Edison Award in the Best New Product in Science and Medical category. In addition, Pankaj has been issued multiple patents in the area of transdermal formulation discovery and novel high-throughput screening platforms. And Pankaj, we're excited to hear more about your science today, but also more about your life outside the lab. So can you first tell us what you like to do when you're not doing science?
Actually, I'm very passionate about cooking, and I'm lucky to be married to someone who enjoys eating, who's a foodie. And so I think that goes quite well. But cooking is a real stress buster for me. I actually find a lot of parallels between doing science and cooking. So that's something I love to do in my spare time.
Oh, wonderful. What do you like to cook?
So I come from India, and there are so many regional variations in the cuisines. You can make the same recipe 6 different ways. And so what we try to do at home is really try out these different variations, the regional variations, different spices, just really experimenting with the protocols and the end results.
I love that. Getting creative in the kitchen, I think, is a lot of fun.
Exactly.
Well, Pankaj, it's wonderful to hear about life outside the lab, but you're doing some remarkable work on the science side as well. So can you tell us how you describe your work to someone who's not in your specific field or perhaps not in science at all?
Sure. I have been trained as an engineer, a chemical engineer. And really what we do is we try to bring engineering fundamentals, technology to solve problems in the biological world. And so what that really means is we try to use engineering and technology to solve problems in human healthcare. And what we hope to do is what we do in the lab translates to making both the quality and quantity of human life better for everybody.
I think that's amazing. And I think doing this translational research can be really motivational and inspirational because you can see the impacts or the potential impacts of the work that you do. But I think being a scientist, there are struggles and tough times as well. And I think it can be helpful to have a motivational quote or a saying or just something that keeps you going when the times get tough. So Pankaj, do you have a favorite quote or a saying or a mantra that really keeps you motivated and inspired?
So I am the kind of person that tries to follow practical wisdom, but there's one quote that has always stuck with me, and it's sometimes ascribed to Mark Twain and sometimes to Arthur Lewis, but the quote goes, "It's not the size of the dog in the fight, but it's the size of the fight in the dog that matters." And not to introduce a pun here, but doing science, you have to be dogged in pursuing your ideas and pursuing your research. And it's not always easy, but that's the beauty of science. You kind of have to convince your peers that your ideas have merit. So being persistent, being dogged is something I try to do. And so I think that quote quite reflects well the day-to-day in science, sometimes the struggles in science.
Definitely. I think the days in the lab can sometimes feel like a battle
Exactly.
when nothing's going right. So that is a wonderful piece of motivation to keep you going. And I think having people that motivate and inspire you around you when you're doing your science can be helpful as well. And I think as a scientist, you meet a lot of people throughout the course of your career. So Pankaj, do you have a particular person or a few people who really rise to the top of your mind as mentors or role models or inspirational figures for you?
Absolutely. And one of the blessings I count for myself is that I've always been so fortunate to have just really amazing, wonderful people that I've had the opportunity to work with. And one such person is my Ph.D. advisor, Samir Mitra-Gothri, who's now at Harvard. And really, I appreciated the business of science by working with him in the early parts of my research career. So I did my Ph.D. with him. But he really taught us how to think through a problem, how to break it down. And then once you believe that you have a solution that can potentially work, don't give up on it. Be persistent, continue to work on it. So definitely Samir has been a great inspiration in my career. But as I said before, I've had the good fortune of having wonderful colleagues, wonderful mentors all along my career, but even students. I've had some stellar students walk through the door who have taught me a lot about not just doing science, but what we often forget is science is a human enterprise. You get to work with people. You have to manage people. You have to collaborate with people. And I've learned a lot of important lessons through some amazing collaborators, students, too many to name, but I feel fortunate that I've had the pleasure to work with so many wonderful people.
Definitely. And I love the comment that you made about the business of science, because I think in a lot of ways, and I've heard this from a lot of people, that running a lab is like running a small business. So I think learning the business of science early on can really help as you start to launch your own independent lab.
Absolutely. I mean, there are days when, as a principal investigator, you feel like you're just a manager because you're writing grants, you're trying to formulate your ideas. And so there are days when I miss that fun, that excitement of seeing the results of your own experiment. Now I have to wait for the students to come to me and tell me that. So I do miss that. I feel a little envious that I don't get to do that as much anymore.
Well, I think this joy of discovery and interest and passion for solving problems and learning those new findings is what drives people to science in the first place in a lot of cases. And I'd love to hear about what maybe first attracted you, Pankaj, to science. So what really sparked your interest initially in engineering or science?
I wish I had an answer that kind of looked like a straight line from point A to B to C, but honestly, my scientific career and journey has been full of serendipities, full of accidents, good, fortunate accidents where I've had people nudge me in the right direction. So I happen to come from a very modest background. Both of my parents did not have the opportunity to go to college. So I always relied on my school teachers, college professors to kind of guide me in what science is, what research is. So I remember when I had finished undergraduate studies, I was thinking, what should I do next? And I felt like I'm not ready to go into the real world yet. I want to stay in school a little bit longer. And I had a wonderful professor when I was an undergraduate, and he really sat me down and he actually showed me what research looks like. And it sounded fascinating. So that made me realize that maybe doing a PhD would be a good thing for me to do at that point. So that's really how the journey began. But coming back to serendipities, when I applied for graduate schools, I was accepted into UC Santa Barbara. And I went into UC Santa Barbara fully knowing that I was going to pick one of the three key research areas. It was either going to be artificial neural networks, which kind of is the foundation for AI ML today, or it would be molecular dynamics simulations, or it would be plasma processing. So I had my mind made up that this is what I'm going to do. And then lo and behold, I show up at Santa Barbara and I listened to a talk by faculty, actually Samir, who had just joined the department. And he was talking about chemical engineers doing drug delivery. And it sounded so disconnected. And then as I heard him talk about it more, he talked about how the foundational principles of chemical engineering, mass transport, diffusion, reaction, kinetics, they all matter to drug delivery. So in an instant, I was like, sign me on. This is what I want to pursue.
Absolutely. And I think these points of transition in your scientific career can be sticking points for a lot of people that transition from undergraduate to graduate school or graduate to postdoc. So can we talk a little bit about your transition? So going to graduate school, you found your way to the University of California, Santa Barbara, all the way from India. What was that transition like for you? Not only starting on this adventure of graduate school, but transitioning to a new country as well.
When I look back and I think about those days, perhaps I was a little foolhardy or naive, so naive that I actually perhaps didn't think through all of the big changes. They just kind of seemed to happen. And I was a little bit brave, I guess. What I did know was I wanted to experience new things. I wanted to be in a new environment. And again, I had a few of my upperclassmen who had gone through this process, and I made sure I talked with them quite a bit before making this decision. So again, I think a little bit of naivety, a little bit of help from people, a lot of good advice. I think that really helped with the transition.
Absolutely. And you mentioned that this talk by your almost to be Ph.D. advisor at the time perhaps got you interested in this area of drug delivery. So what then were some of these key moments that really took you from that point as an enthusiastic Ph.D. student to where you are today, Pankaj?
It started by eating the humble pie. So I actually did not have any particular love for biology. In fact, I tried to stay away from biology. And the simple reason for that was my sister has an advanced degree in microbiology. And so obviously you don't want to do what your elder sister does, right? And so
Right.
That was my reason to stay away from biology. And then I was so fascinated by this idea of drug delivery. And then it suddenly occurred to me, oh boy, I need to go back and learn everything that I've consciously chosen not to, which included molecular biology, cell biology, physiology, anatomy. And I had to learn all of that to be able to do my research. But from that came a very profound sort of realization. There is another really good Arthur Lewis quote. It says, "Don't let schooling get in the way of education." And I came from a system that was 30 years old in India now, fairly rigid. And here was an opportunity where I was going to the library and reading textbooks and learning about things that I would use in my research, not because somebody had told me to do it, not because it was part of a class, but I had to. I needed it for my research. And I honestly think that was a very profound experience of rediscovering this thirst for knowledge. So even though it was a very difficult first year of transitioning, looking back, I think it really taught me some good values, good fundamentals of how to approach science, how to approach learning in general. And it has also helped me in teaching. I kind of try to put myself in my students' shoes and try and understand what they're going through. So I think it really helped make me a better teacher as well.
Oh, absolutely. And I think as you're approaching the end of your graduate school days, the big decision that sort of looms over everybody's head is what you want to do next. And everybody's asking you, so how did you make that decision that you wanted to do a postdoc at MIT?
It wasn't easy. I think I struggled with it for a good year or so, whether I wanted to go into industry, whether I wanted to go into academia, and if so, would I want to go do a postdoc? And I think what helped was really talking with people, both in industry and academia. And again, my advisor was a big resource. And what I realized was I kind of had to look inward. I had to do some introspection about what makes me happy, because I don't think that there is an ideal job. I think there is a job that's good for you if it matches well with what you want out of it. And being in graduate school was like expanding in vacuum for me. I really loved the experience. I had been away from biology, but then I actually started learning more about it because I wanted to. I think those experiences collectively told me that I love pursuing my own ideas, pursuing my own thoughts. And I felt that academia kind of gives you that flexibility, that bandwidth, that freedom. It, of course, comes with the responsibility of having to raise your own grants, support students, support postdocs, but evaluating that balance of freedom versus responsibilities to your junior scientist, staff, students, I felt that that was a career path I would enjoy, and I do not regret making that decision.
So what was your experience like then at MIT?
MIT was fantastic. I was lucky in some ways. Even before I defended my PhD, I had started interviewing for faculty positions, and I had an offer from our PI. And the dean of School of Engineering at that point was very flexible. He said, look, if you want to go away for 2 years, do a postdoc and then come back, that's totally fine with us. In fact, we would want you to gain new experiences. So I signed up my faculty position offer 2 years before I joined. But then it allowed me to go to MIT for 2 years. And what I did with that was I completely changed my research direction. My background was in drug delivery, but what I did for 2 years at MIT in Dane Wittrup's lab was protein engineering. Again, something that I had to relearn. In fact, I would buy lunches for a junior graduate student in the lab who would teach me the skills, yeast display, even doing recombinant DNA. It was not something I had done in the past. So it was a tough learning period, but again, thoroughly enjoyable. Looking back, I think my research program has benefited from it because I had these two orthogonal experiences, one in the area of drug delivery and the other in the area of molecular engineering, protein engineering. And I think we've been able to really synergize those two complementary skill sets in the kind of research that we do today.
I think that's remarkable. It's really cool that you've, Pankaj, reinvented yourself a few times in your career. And I think that's something that people are often afraid to do. Was this something that you had any hesitations about, or was it just like, okay, we're just going to learn a new skill today?
It goes back to me being a little bit foolhardy sometimes. I think I'm a sucker for pain sometimes. I learn things the hard way, but I think there is a joy in learning new things, and that's what keeps me going. I think even in the 15 years of my career at RPI, we have worked on drug delivery, tissue engineering. We have worked on bioseparations. We have worked on crystal engineering. And I think that kind of keeps me excited about doing research. So I'm always up for learning new things, starting new collaborations. I think it helps you be a lifelong student in some ways.
Absolutely. And I'd love to talk more about your research at RPI. You're doing some remarkable work. So do you have a favorite project going on at the moment, Pankaj, that you are the most excited about and want to share with us today?
Sure. So we had a really nice paper come out just recently in Science Advances, where we have shown that we can 3D bioprint human hair follicles in skin. And really, this work started about 10, 12 years ago when I had just started at RPI. And at that time, 3D printing was more of an interest, not necessarily a research field. But we were one of the first few groups to show that we can use 3D bioprinting of cells, proteins, matrix molecules to actually create these layered tissues. And skin is a great example of it because it's already pretty layered, pretty hierarchical. So back in 2012, we had published a paper on showing that you can actually take these cells, you can put them through the pressure and the shear of going through a needle being printed in layers, and they actually survive. They proliferate. And what you get at the end of it is something that resembles a human tissue. So we were very excited by that. Our next step was we were able to show that we can incorporate vasculature in the skin tissues. And that was a first. Right now, even with the skin grafts that are used on patients in the clinic, there is no vasculature. And what that means is that these grafts slough off. They really are fancy Band-Aids. They stay on the wound for a little bit, but eventually, because they don't have blood vessels, they don't have a way of connecting to the host. And so they slough off. And we were able to show that if you embed a vascular network in these tissues, they actually stay on, they integrate with the host. So for us, that was a big success. And then about 6 years ago, and this is where, again, I mentioned serendipity in my research career, but I was at a World Congress of Alternatives to Animals in lab testing. This was a meeting in Prague, and I gave a talk on our 3D skin printing work. And at the end of my talk, this young woman approached me and said, "Hey, can I join your lab? And I'm interested in hair follicles." I was like, wait, what?
Right.
I don't have the first clue about hair follicle biology. But she was adamant. She was persistent. She chased me down. And I was like, okay, great. Let's start this. So the paper that we just published has been the culmination of almost 6 years of research led by this wonderful, talented young woman, Carolina Catarino, who is now a scientist at a company in Brazil, Grupo Boticário. So we are super excited about this work. Where we really want to take this is to design better skin grafts for regenerative medicine. But we want to make grafts that have as many of the physiological structures that are present in native skin, whether it's hair follicles, sweat glands, whether it's the right pigmentation. These are not just things that are important aesthetically, but they're also important for wound healing, for better clinical outcomes in patients. So that's really what we are super excited about right now.
Absolutely. And Pankaj, if you could maybe elaborate a little bit on just the significance of incorporating these hair follicles specifically in the tissue models. What does that get you in terms of better outcomes or things that would be relevant clinically?
So there are two end goals here. One is certainly better clinical outcomes. So when we think about hair follicles, Generally, we think of hair as being something, aesthetically important, right? But if you look at this organ, this mini organ, it's fascinating. The hair follicle bulge is home to stem cells of the skin. So when you have injury or wound, these cells migrate out of this bulge to the site of injury. They differentiate, they change phenotypes, and they help with the wound healing process. So from the standpoint of better wound healing, the hair follicles are really critical and really important. And I think the incorporation of hair follicles along with the vascular networks in tissue grafts can result in better clinical outcomes. But on the other hand, we often don't think about it, but the hair follicle is actually a route of penetration of foreign agents that the skin is exposed to. And right now, to test the toxicity or even the potency, efficacy of a topical formulation, you would have to put it on an animal, right? Because there are no skin models right now, in vitro skin models that have hair follicles. And so these studies have to be done in animals, which I think within the next half a decade or so are going to get phased out. So we do need better models to understand if something that's topically applied to the skin or something that skin is exposed to, is there a chance of that agent to go through the follicular route, enter systemically, and cause systemic toxicity? So even from an understanding standpoint or from the standpoint of developing efficacy platforms, I think such models are quite important.
Certainly. Well, I love that your work has these two different sides, both the research relevance in terms of developing these tissue models, as well as the potential clinical applications of the amazing work that you're doing. And listeners, if you're interested in learning more about amazing science, New England Biolab's podcast, Lessons from Lab and Life, is your source for staying informed about the most up-to-date molecular biology breakthroughs. Host Lydia Morrison interviews prominent scientists and delves into their research to uncover how their findings affect society in meaningful ways. Tune in to learn from the experts and get a glimpse of the cutting-edge advancements being made by scientists around the globe. Don't miss out on this opportunity to gain new knowledge and stay informed on the latest discoveries. Tune in to Lessons from Lab and Life today, wherever you listen to podcasts. And Pankaj, you introduced us to your research earlier, and I think you make it sound easy. But I know it's not. I know in science there are challenges and struggles, and oftentimes they happen all at once. So do you have a story that you could share that involves a major failure or a struggle that you've had or a challenge that you're facing right now?
How much time do we have?
Right.
I'll pick one. I think about 5 or 6 years ago, when we were working on building these vascular networks in the skin, we had not appreciated how beautiful biology is. If you think about the cells of the skin and the cells of the vasculature, endothelial cells and keratinocytes, in the skin, they're separated by maybe 150, 200 microns. But they require very different conditions to survive. And our biological system, our physiological system somehow makes it such that these cells are happy in their niche. But then when you try to take these cells separately and try to culture them in the lab by putting them together, they just don't like it. So we spent about a year and a half trying to build these vascular networks in the 3 dimensions. And all we would see is the endothelial cells just collapse and settle at the bottom, without really forming these lumen structures or microcapillaries. And it was very humbling. So eventually we were able to solve that challenge by changing media conditions, by changing calcium content. But it really underscores how complex, how sophisticated, and how beautiful biology is, biological systems are.
Oh, absolutely. And was there a point during this sort of year and a half of struggle where you thought about just scrapping that line of research and refocusing?
I have to admit, there was one breakdown point, and this was a project in partnership with investigators, researchers at Yale University. And they would go through this very meticulous process of isolating human cells, these progenitor cells, to form the right kind of endothelial cells for us to be able to print. And we would often just ship this material overnight through FedEx in a cold pack. And there was one instance where we had lined up all of these experiments. We were just ready to go. We had figured out all the right conditions. We were just waiting on the cells from Yale. And the FedEx delivery person just took the box to the wrong address, and it sat out there, which killed all the cells, which months and months of work just went to waste. And that was a real breakdown point for all of us in the lab. And we just kind of had to pick ourselves up and start all over again. But these are the things that seem mundane, but those are things that happen in a lab. Those are things that happen in research. And you just kind of have to get up, dust yourself, and just start again.
Absolutely. I think that perseverance is key, being dogged, as you mentioned earlier in the conversation.
Exactly.
Well, we don't just want to focus on these tough times, Pankaj. I'd love to talk about some of your successes as well. You sort of hinted at a few of them earlier in our conversation, but do you have a favorite success story or maybe a small but particularly meaningful win that you've had lately?
I think this work on hair follicle incorporation in skin, we're really excited about it because it has been a challenge in the scientific community. And quite honestly, we received a lot of pushback, whether it was grant reviews or reviews of our publication. It took a lot to convince people that we can do this, we are doing this, and now look, we have done this. So once the paper was accepted and it was in Science Advances, it felt really good. It felt like all of this persistence, perseverance had paid off. But more importantly, we were right in our beliefs that we can make this happen. So talking about recent past, I think that's just a beautiful moment that we got to savor.
Well, I think those I told you so moments are really wonderful to experience in science when you do finally convince people, you get that paper out there. So how did you celebrate when you got that final acceptance of the manuscript?
I wish all of the folks who worked with me were at RPI. So the lead author, Carolina, she is back in Brazil now. One of the undergraduates who worked on this project has moved on. She's in industry. So there I was in my office alone with a bottle of champagne and doing a Zoom call with everybody, telling them about the fantastic news. But I did get a chance to meet with Carol after that, and we did celebrate. But yeah, I wish we had everybody in the same room physically. Unfortunately, we had to do a little celebratory toast over Zoom.
Well, we're all very well versed in Zoom, I think, these days, so at least makes that smooth.
Exactly.
Well, Pankaj, it sounds like this was a very exciting success for you in the group. So what is next in this line of research?
So there are two things. Those are really close to my heart. One is we have been able to show that we get these early follicular structures to form in the skin. But these are short-term studies. We can only go about 4 or 5 weeks at most in the lab. The real proof that this works will come from fabricating these tissues in the lab, getting the hair follicles in them, but then putting them on a wound in an animal model and then seeing if we really get the growth of hair shafts from these follicular structures. Do they mature? And how well or not well do they mature in situ versus in vitro? So there are a lot of these fundamentally important questions that we would love to explore. But there's also another pet research idea that I've been wanting to work on, and we just haven't had the right factors come together. I talked earlier about the incorporation of blood vessels and vasculature in skin grafts, and it's somewhat of a catch-22. Grafts that don't have blood vessels slough off, they don't integrate with the host. But then grafts with endothelial cells, they have a better potential to integrate, but they are also likely to cause an immune response, an immune rejection. So you have this catch-22 almost. But what we would love to do is use the power of CRISPR-Cas editing to try and see if we can shut down the immune markers on these cells, even for a short period of time. Because what that would mean is a sort of universal graft or a type 0 graft for patients. Right now, the way to actually design a personalized graft for a patient would be to isolate the cells, grow them, culture them, print them, then bring those printed grafts back to the patients. And oftentimes patients don't have that much time, especially if you have severe burns. Many of these fatalities happen because of opportunistic infections. But think about a scenario where these universal grafts have been prefabricated, pre-printed, they're available for the surgeon in the clinic to just put them on when the patient walks in through the door. I think that would be a real game changer. So that's a pet research idea that I've been thinking about for a while, and we just haven't had yet a chance to start work on it. But that's something I would love to do as some of the next steps in this research.
Well, this sounds like a fascinating project, and I'm curious about just this process of 3D printing these complex tissues. So is there a limit in terms of the size, the shape, what you can make with them, or is it pretty open-ended?
It is, because if you think about it, at the end of the day, it is just automation, and you can multiplex, right? You can have multiple printing arms. So right now we can print maybe an inch by inch piece of tissue, but that's because we have a single printing arm. But if you were to multiplex maybe say 24 arms, you could print a 4 feet by 4 feet tissue in less than an hour. So I always tell people, what 3D bioprinting is going to do for tissue engineering is what the clean room has done for the semiconductor industry. It has brought in a lot of automation, high throughput. It has minimized human intervention, which is very important when you're talking about biological tissues, because you have to have a sterile environment. You have to keep human intervention to a minimum to avoid infections, contaminations. So I think the scaling up of this technology, I do not see it as a challenge because it has been done in other areas of translation, whether it's in the biological space or in the physical space.
Oh, this is absolutely fascinating, Pankaj. I think you're doing amazing work in this space. And I think being able to work on these super exciting projects in science can motivate you to kind of spend even more and more time in the lab. And I think we try to get our listeners to take a break at least once in a while to give their mind a rest and to think about something that might be outside of their immediate scientific discipline. And one of the great ways to do this is by reading broadly. So we love getting book recommendations from everybody we feature on the show. So Pankaj, do you have a favorite book that you've read, whether it's related to science or not, that you can recommend for all of us?
I'll preface my answer first by saying, the last year and a half, so we have now a toddler at home. Mm-hmm. So the last year, my reading has been limited to Dr. Seuss and Sandra Boynton.
Those are great books.
And Old MacDonald and Thomas the Engine. But there are a couple of books that I read. I think Premonition by Michael Lewis was a great read. It also had, for me, personal connections to, Santa Barbara. There's another really good book by Charles Mann called The Wizard and the Prophet. And it describes beautifully the two aspects of any scientific challenge that we deal with. And climate change is a great one. There is sort of the prophecy of the doom impending us if we don't do anything. And that's sort of the prophet part of it. And then the wizard part is engineers, technologists, innovators coming together and saying, we have to create new solutions, new innovations to address these issues. And sort of this push and pull between the prophet and the wizard, I think it's beautifully captured in this book by Charles Mann. So I would certainly recommend this. I found it personally to be a very enjoyable read.
Oh, well, excellent recommendations, Pankaj. And I think you're the first person to recommend both of these books, Premonition, listeners, and The Wizard and the Prophet. We will add these to our book list on our website for everyone to find there if you were looking for your next great read. And we talked about some different aspects of your career, Pankaj, but one of the things we haven't yet touched on is travel. I think this is a huge part of life in science. So do you have a favorite place that you have traveled for science, whether it was for a conference or other purposes?
Yes. So we were literally just last month in Scandinavia, and what made this trip especially fun was I was able to travel both with my wife and our young toddler, and it was fantastic. I was able to bring him to the Nobel Prize Museum in Stockholm, just trying to subliminally get him into science. But whenever there is a conference in an interesting place, I always try to bring family and always try to take a little bit time to kind of appreciate the opportunity, the privilege that we have, that we do get to explore these new places, travel new places. Otherwise, the monotony of work gets in the way.
Definitely. So what was the occasion that brought you to Scandinavia?
So I was invited to review a center at the University of Copenhagen in Denmark. And since we were going to be in Denmark, both me and my wife have friends in Sweden and in Norway. And it was around Thanksgiving time. So we figured we've had a tradition of always celebrating Thanksgiving with friends and family. So this also allowed us to combine Thanksgiving celebrations with friends with a little bit of work, a little bit of sightseeing, and just giving some new experiences to our baby.
Oh, that's wonderful. So what were some of the most memorable sights that you saw while you were there?
So we actually were able to have dinner at, I think it's almost a 150-year-old place.
Oh, wow.
And apparently they have a dinner table reserved for the members of the Nobel Prize Committee.
That's so cool.
So we felt we were in hallowed grounds because this was the place where discussions on who wins the next Nobel Prize apparently happen. So being able to dine there, be able to go to the Nobel Prize Museum, that was great. We were able to go to the Opera House in Oslo, which was just fantastic. It was a beautiful experience to see the Opera House. And then just, again, taking some downtime with friends who we hadn't seen for a while was a lot of fun too.
Oh, absolutely. I think that's another sort of unspoken perk in science, is that you do develop these friendships, these relationships with people all over the world that you see every year at conferences, or that you've collaborated with over the years or worked with over the years. And I think these people are another part of what makes science so wonderful, despite how scientists are often portrayed in the media, unfortunately, as these very serious, critical, no fun sort of people always working in the lab. But that is contrary to so many of the personalities and just experiences of of people that I've met. So Pankaj, do you have an experience of a quirky tradition that you've had in a lab, or maybe just a fun or funny memory that you've shared with colleagues that go against this very serious side of science that people often get to see in the media?
Yeah, absolutely. I distinctly remember when I was a graduate student at UC Santa Barbara. Now, we're talking about the early 2000s, right? Mm-hmm. One of the things we would do is after finishing up the day in the lab, we would come back to the lab at around 9:30 or 10 in the night. And we would play this multiplayer game called Call of Duty. And back then, the university was the only place you would find really good high-speed internet connections. Mm-hmm. So we would all huddle into the lab, turn off the lights, put headphones on, and play this game. And then one day, we were really in the middle of it, completely oblivious to the fact that our advisor had just walked into the lab. And we all just froze and were expecting a complete dressing down. And his reaction was, he looked at us, he smiled and said, "Carry on," and he just walked away.
Oh, he didn't join you.
But what was fun about this was it was a really good team building exercise. I think my lab mates from that time, my peers in the lab at that time, we still have very strong connections, not just scientific, but even outside. Many of those have attended my wedding, many of whose weddings I have attended. Like you said before, it truly creates this extended scientific family. And it just keeps growing and growing, which I think is one of the biggest perks of being in science.
Oh, absolutely. And I think having this sense of community and feeling like family in the lab can be really helpful because you are going through some difficult times. You're trying to make some really difficult things work. And I think having that support network can be tremendously valuable as you solve these big problems because there are, as we mentioned, a lot of challenges, a lot of limitations. So whether it's just the funding or feasibility or time or just logistics of the project that you're trying to do, if we took away all of the barriers that normally hold you back, Pankaj, what is the one research question or problem that you would want to tackle most?
I think I mentioned this before. If we can create these universal skin grafts that are somewhat agnostic to a person, that could be prefabricated, that could be made ahead of time, I think it would be a real game changer. It's going to be a lot of work requiring a lot of resources, multiple skill sets. But if I could, and I won't be, but if I could drop everything and pick just one thing to work on, I think this would be something that I would really love to. It's something very close to my heart. Being able to create these tissues ahead of time and not have to wait to extract cells from patients, wait to culture them, wait to print them, fabricate them. I think it would go a long way in what I describe, at least my mission in our work is to improve both the quality and the quantity of human life.
Absolutely. And in terms of the barriers, you mentioned if you could drop everything and work on this, this is what you would do. What is holding you back? Is it the technology? Is it just a resources, time, funding situation? What is preventing you from getting at that ultimate goal now?
I think it's a confluence of many, if all of those factors. I think sometimes you have to find just the right collaborator, the right student. You have to have the right resources, equipments, and it takes time to build that. So I would say while we are working actively on it, we aren't there yet to fully take on this challenge. But that's something that my lab is working on with slow and steady steps.
Well, I think this is a very exciting project, and we look forward to following your lab and continuing to see progress on this over the years, Pankaj. And I know we've covered a lot of ground in our conversation today. I'd love to end with advice. So for our listeners out there who might be going through their own struggles, do you have a piece of advice that really helped you at some point that you can share with them today?
I don't know if somebody gave me this advice verbatim, but it's certainly a distilled down version of many different pieces of advice given to me by my mentors, peers, which I follow now. And that's don't let others tell you what you can or cannot do. If you truly believe you have a good idea and you've critically analyzed it and you believe in its potential, then keep at it. The no's will turn into yeses. If you persevere, I think you will be able to bring your ideas and your goals to fruition. So just believe in yourself. I know it gets hard, especially when things are not going in your favor, but just staying in there and fighting it out eventually gets you there.
I think that is phenomenal advice. And not only not letting other people talk you out of these things that you want to do, but don't talk yourself out of them either. Don't limit yourself before you try. I see that so often in science as well.
Absolutely. And you're so right. Don't even let yourself tell you that you can't do this. That's so true.
Well, Pankaj, if our listeners are curious and they want to learn more about you and the wonderful work that you're doing, what is the best way for them to do so?
I always love receiving an email. So my email address is KARANDE np@rpi.edu. Our research work is also on my faculty webpage on rpi.edu. I maintain an active LinkedIn profile where we share our accomplishments, we share our views on research. The viewers are more than welcome to visit my LinkedIn profile or leave thoughts and notes and comments behind for us. But yeah, those are 2 or 3 great ways to get in touch with me.
Fantastic. Well, thank you for sharing those resources, listeners. Definitely check out the website. Get connected with Pankaj if you have questions or you'd like to learn more. And Pankaj, it's been such a pleasure to chat with you today. Thank you so much for your time.
Thank you so much. It really has been a treat and a pleasure. I loved our chat. Thank you for having me over.
Well, it's been wonderful to learn more about you and the work that you do. And listeners, always great to have you here with us as well. We hope you join us again next time for another episode of People Behind the Science.